In previous lessons, we have learnt that in the 5G era, there will be three application scenarios: eMBB, URLLC, and MMTC. Each scenario, with many potential new different services, will impose various requirements on 5G networks. In general, we can summarize the network requirements as follows: 3 highs, 2 lows, and 1 fast. 3 highs refers to high data rate, high connection density, and high mobility. 2 lows refers to low latency and low cost. 1 fast refers to fast service deployment. Among the requirements, low cost is one of the preconditions for operators to efficiently deploy 5G networks. Network costs consist of the engineering and operation and maintenance, or O&M, expenditures. With regards to engineering costs, we know that the 5G network architecture lies in a core technology, Network Function Virtualization, or NFV. This technology intends to decouple upper layer software from underlying hardware. In other words, the functions of 5G network devices will be realized by software packages installed on common servers, greatly reducing device procurement costs. Speaking of O&M costs, we also learned from previous courses that 5G network architecture will become increasingly complex in the future. A large number of radio access technologies, or RATs, will coexist together. Multiple frequency bands will be in operation at the same time, and heterogeneous networking, combined by macro base stations, micro base stations, and small cells, is going to become an increasing trend. Not only that, but new 5G services are continuing to emerge. To accommodate these new services, we have to divide physical 5G networks into logical networks, turning networks into an end-to-end, or E2E, cloud-based layered architecture. As such, operators face greater challenges in performing O&M in traditional networks. If we continue to follow the existing O&M mode, future O&M costs will become extremely high and even grow to account for more than 70% of operation revenue. This is why operators face a compelling need for O&M transformation. This is also the focus of our class today: automated and intelligent O&M. First, let's check out the O&M transformation. The traditional O&M mode is a network-based manual operation, which is conducted through a top-down vertical architecture. It mainly focuses on the trouble-free operation of devices. This mode is suitable for traditional channel services, voice and data transmission, since the quality of service, or QoS, requirements on basic voice services are identical worldwide. Operators only need to build and manage the service channels segment by segment, then launch the services by joining segments through communication protocols. However, a chimney-type O&M architecture fails to support 5G services, which are more diverse and require higher agility in order to go online. Meanwhile, the traditional O&M mode is rather time-consuming and inefficient during service requirement analysis to final implementation. The future O&M may be service-centric, automatic, and conducted in a layered architecture. What matters most are the smooth E2E experience and quality assurance. Relatively independent teams from different domains are responsible for service experience and operation. Traditional chimney-style O&M organization is no longer in operation. In addition, underlying network devices will evolve into universal cloud-based hardware, decoupled from upper-layer service functions in the future. A unified cloud-based and management platform is built to implement automatic and intelligent O&M. O&M, originally performed in a vertical architecture, will shift to a layered mode to adapt to 5G cloudification, function virtualization, and business model transformation. Currently, there are 3 roles in the traditional network: 2G, 3G, and 4G O&M. The Field Maintenance Engineer, or FME, performs preventive maintenance inspection, or PMI, and on-site maintenance for equipment rooms. The Front Office, or FO, is responsible for network monitoring and trouble ticket dispatching. The Back Office, or BO, is responsible for in-depth network analysis, troubleshooting, and emergency assurance. With the development of 5G networks, O&M architecture will change as follows. On-site maintenance engineers remain necessary for fundamental operations. Board replacement, cable adjustment, and other on-site maintenance still need to be done by hand. However, with automatic O&M technologies deployed, for example, unattended equipment room, the number of necessary personnel may decrease. On the other hand, considering that the O&M infrastructure will be cloudified, IT maintenance personnel here will be added. At network level, it is widely predicted that traditional and cloud-based networks will coexist and evolve together for at least 5 years. In this case, existing devices providing physical network function, or PNF, and added VNF devices must be maintained simultaneously. At the application layer, software developers start to use automatic tools and methods to improve the O&M efficiency of fundamental networks. Exclusive Application Programming Interfaces, or APIs, are used to enable innovation for upper layer services and vertical industries. Furthermore, in order to integrate the application and network layers to form a system, a dedicated team is required. The shift of O&M mode is not a step in place, but requires a gradual evolution. In the 3G, 4G era, the traditional telecom network architectures is based on the PNF, or, as we mentioned earlier, is network-centric. In the early phase of 5G network construction, EMBB is the principal application scenario, with 2C, consumer-oriented services, the mainstream. There are few requirements on vertical industries so far, and the commercial slicing is still at a budding stage. The predominant change during this period is the virtualization of core network elements, so traditional maintenance staff must be equipped with IT capabilities accordingly. The O&M of core networks should also shift from perpendicular to horizontal execution. Meanwhile, operators start to attempt E2E O&M architectures and methods to accumulate experience at the application layer in order to maintain some typical 2C services, such as HD video or VR, and 2B services, such as video surveillance in EMBB scenarios. When 5G matures, network cloudification and virtualization are further strengthened. On the unified cloud infrastructure layer, 2B industry applications become the main 5G business scenarios. URLLC and MMTC will further promote the application of network slicing. At this time, basic network O&M and application O&M are gradually isolated. In terms of O&M application, operators need to launch dedicated O&M architectures for vertical industries and deploy DevOps, development and operation mode, in order to provide services. For instance, operators can directly approach certain vertical industries by offering E2E application designs and integration. As 5G networks and IT services begin to become increasingly cloud-based, automation and intelligence are gradually introduced into the basic O&M. What are automation and intelligence? Standardized process following clear rules with certainty can be referred as automation. For example, the alarm handling process, including fault locating, trouble ticket dispatching, troubleshooting, and result verification, is pretty clear. It specifies the time, executors, actions, and operation steps. This is a great example of automation. The preceding process and all actions are automatically connected to the IT system to improve network O&M efficiency. The focus so far has been on streamlining workflow, clarifying operation regulations, simplifying working processes, and then eventually automating all repetitive work. Clear rules and fixed workflow contribute to the process of standardization and the development of automated approach. What if the rules are ambiguous and actions are not certain? We think intelligence is the way forward. In the case of unclear rules and uncertain implementation actions, we need artificial intelligence, or AI, to assist the process, which is called intellectualization. Typical intelligent application scenarios are the root cause analysis of faults and performance problems, as well as the prediction of network performance deterioration. After AI is introduced, the efficiency of problem analysis is greatly improved. AI accumulates historical data on the network and masters certain rules by learning from an enormous amount of data from across a long period. In this way, AI can predict the probability of problems in order to take preventative actions. For instance, after intelligence is introduced to the O&M of network devices, the AI-based O&M can obtain monthly traffic growth rates by analyzing the traffic load over the last 12 months. It is also capable of expanding the capacity in advance to avoid network overload. If the traffic load in next month is predicted to exceed the capacity expansion threshold of the network devices. In summary, the O&M of fundamental networks will be both automated and intelligent in the near future. Now we are going to share two case samples about the new O&M. In a shopping mall, a single floor is only covered by 3 cells. Internet user experience is good on weekdays as there is little passenger flow at this time. Yet, when it comes to the weekend, traffic requirements sharply increase, far exceeding the capacity of 3 cells. Many users at the weekend complained about the low data rate. If the automatic and intelligent O&M is adopted, the network management system running background can automatically detect variations in the traffic volume in accordance with passenger flow. When traffic is high, the 3 cells will be split into 4 cells to enhance the capacity. When the passenger flow is reduced, so is the traffic requirement. The system again automatically aggregates the 4 cells into 3 to decrease interference and release resources. Apart from this, intelligent O&M system can establish algorithm models about traffic volume by machine learning Moore's historical data over the past few months. The intelligent system can predict future traffic and automatically split and merge cells when it is necessary, always keeping the network architecture in the best state. Another example refers to the detection of hidden abnormalities. In wireless networks, call drop KPIs must be monitored. The traditional detection method is to configure a performance alarm threshold based on experience. As a result, exceptions that are hidden in periodic data cannot be identified. If the fixed threshold is set to 1%, the performance alarm is reported only when the call drop rate is higher than 1%. As shown in the figure, there are 2 abnormal periods when KPIs exceeding the threshold trigger the alarms. However, there still remains a performance exception at night. The call drop rate is 0.8%, lower than 1% threshold, but is still abnormal given it occurs in off-peak hours. Normally, the lower the traffic load, the lower the call drop rate. However, this abnormality cannot be detected by traditional O&M methods. Automatic and intelligent O&M can be performed to obtain the periodic change rules of traffic load through machine learning and massive data analysis. In this way, the dynamic threshold can be set by referring to the periodic data and modeling, and therefore invisible exceptions are identified. In this lesson, we talked about the features of 5G networks, O&M transformation, and new O&M cases. We have learned that 5G O&M will be automated and intelligent. Only with these 2 goals achieved can the network O&M cost be slashed. That's all for this class. In our next lesson, we will discuss 5G industry applications, including automated driving.